to determine the value of the parameter in the simple harmonic motion, we can do as follow. First, the value of the omega is equal to the square root of k over m. So it means that the value of the omega is determined by the character, not the character, but by the property of the system. It means that you have to know the spin constant and the mass of the object. It's not directly related to the motion of the object, but it is the property of the system that is depend on k and m. Okay. Next, we can see that the parameter a and phi can be determined by the initial condition. The initial condition of the motion, and what we mean by the initial condition, that is the value of the position at time equal to 0 and the velocity at time equal to 0. This is a choice of initial condition. It is not necessary to use x and v as the initial condition, but this is a convenient choice, because if we take the time equal to 0 at the initial time, we can use this as the initial condition of the motion. So we must have that x0 is equal to a cos phi, and also v0 is equal to the minus omega a sin phi. Okay, so it means that if we solve these two equations, this equation and this equation, we have two equations with two variable, that is, or two unknown, that is the a and phi. So we can solve this to get a and phi from the initial condition, and you can see that this is if we divide the second equation by the first equation, we have that v0 over x0 is equal to minus omega sin phi over cos phi, which is equal to the minus omega of tan phi. Since omega can be determined from the property of the system, so from this equation we can get the value of phi. Okay, and once we have the value of phi, we can substitute in this equation or this equation to get the value of a. Okay, so this is a method to determine the parameter of the simple harmonic motion.